All right, welcome to lesson 3, radicals and fractional exponents. So what we're going to be doing in this lesson is figuring out how we can go from a radical expression to a fractional exponent because they are actually the same thing. So we're going to start off by just using our calculators to evaluate each of the following to 3 decimal places, and I want you to go across, not down. Okay, so basically this is something that we want to look at. Okay, so we're going to do these 3 and look and compare them, and then the next 3, etc., etc. Okay, so if you take your calculator and you put in the square root of 8, you'll notice it's 2.828, and we already know that if I change that into a mixed radical to root 2, those are equivalent. And now I'm going to ask you to do 8 to the power of 1/2. So you'll have to find your exponent button on your calculator, whether it's the hat button, the x to the y. You may have to enter it, like I know on my calculator, I have to go 8, half, open up a bracket, and then one either divide by 2 or the fraction button 2. Okay, so when you do that, you get also 2.828. Okay, the square root of 32 is 5.657. 5.657. 32 to the half is 5.657. Okay, I want you to pause the video right now, and I want you to fill in the remainder of these questions. Then come back and check. All right, so here we have all of our values. So I want you kind of to compare the beginning and the end. Okay, so we're looking, I mean, we know that the decimals are the same, obviously. So now I want you to also look at the questions, right? And see if we can figure out how we're getting, so how the cube root of 16 is the same as 16 to the 1/3. Fifth root of 64 is 64 to the 1/2. Root 2 cubed is 2 to the 3/2. Cube root of 3 squared is 3 to the 2/3. Okay, so what do we notice about these? Well, the first thing that you should notice is that the base of the exponent is the same as the radicand. Okay, so it's the same as the number underneath there in all cases. So that's the first thing that you should notice. And then if you look a little bit closer, maybe you notice that the denominator is the same as the index. Remember, it implied 2 there, 3, 3. Okay, and the numerator, so in the first ones, there was kind of no, the numerator was a 1. But if you notice here, the numerator is the number, the exponent. So in general, we can say that if I have an nth root of x to the m, it equals x to the m over n. And the way that I remember it, and it sounds silly, but the way that I remember it is I think denominator in the notch. Okay, so the denominator goes in the notch of the square root sign. Now, you may also see, like just so that you know, it could also be written as the nth root of x in brackets to the power of m. You might see it looking like this. Okay, it doesn't really matter. It's just that the denominator goes as the index and the numerator is an exponent on that number. So we're going to go ahead and practice with this. Okay, so our first examples are, we're just writing each radical as a fractional exponent. Okay, so remember that the number, the big number, is your base. So it's going to be 5. Denominator in the notch. Okay, so it means my denominator is going to be 3, and then 2/3 will be my other one. 9 Okay, now denominator into notch. So remember that on a square root, it's an implied 2. So my denominator is a 2 and my numerator is a 3. And on this guy, I have a base of 2. My denominator will be 5 and my numerator will be 4. Okay. Second examples are writing each fractional exponent as a radical. So again, now the 5 to the power of 2/3, so the 5 goes underneath there. Denominator into notch. This will be a cube root of 5, and then you can write your 2 either right underneath there, or if you write it like that, those are equivalent expressions, okay? 7 to the 5/2, so I've got a 7. There's my root sign, denominator in the notch, so it's going to be a 2 that's implied, and then I've got a power of 5. Okay, and then, by the way, if you do write the 2 here, that's fine. I will not take that off, but you don't need to write it because it isn't implied. All right, 3 to the 3/4, so there's my root sign. 3, denominator is 4 to the power of 3. I'll write this one underneath there. So I wrote all those a little bit differently. Those all mean the same thing, okay? All right, just lastly, let's look at evaluating these things. So evaluate means to get an answer, okay? So that means get an answer, like figure out what it is. So 8 to the 2/3. So what I want you to do is write these in radical form. So this becomes the cube root of 8 squared. So the cube root of 8 is 2 squared, which is 4. 64 to the 5/2 is a square root of 64 to the power of 5. So when we're evaluating, I like to leave the exponent on the outside here because usually, like if I was to do 64 to the power of 5, it's going to be this huge giant number. And I don't really want to do that. So the square root of 64 is 8. And then 8 to the power of 5 is 32,768. Okay. So that is practice with going back and forth between fractions and radicals. So you go ahead and work on the practice questions now.